gentlemen, we have returned. We are back. No more road trips till next year. All my business all over the United States is completed. Almost 15,000 miles worth of driving this summer. And about 2 or 3 dozen customers, all happy. And I mean that seriously. Like, when I left out this last leg, I had to go to Ohio to drop off at 3,000, and I picked up 5 amplifiers on the way home. Big tube linears, so plenty of stuff going on. Let's start doing some RO repairs. This is for my customer Matt, and it's RO number 53. He bought this in 2024, so it's an old model, or a new model, pardon me. We can tell that by the case. Completely different coating on the case. He sent everything with it, power cord, mounting brackets, everything. The notes say here, only getting 100 watts out, replace transistors with Toshibas, upgrade power wire, adjust fan so it comes on sooner, possibly add fan on top for more cooling. I use on digital modes F8 and F4. Usually drive with 25 to 30 watts. In on ding. Okay. 65 watts on sideband. I use a 14.7 volt power supply to 15 volts from the power supply. Okay. That's pretty clear. When I spoke with him this morning, he said that he's getting roughly 100 watts out of this thing and nothing more. He feels there might be a problem with one of the transistors. I agree with him. There's definitely something wrong. So, this thing doesn't have a scuff mark on it, one, except for this little smudge, which is kind of oil on the top of the lid. And we'll do everything we can to maintain the quality here. He wants me to add a new fan on the top, so we're going to give him a 120 millimeter fan right here on the lid. Right there. So the air can go in and come directly out and cool off all the parts that are important. When this thing was designed 1 billion years ago, 35 years ago, the digital mode thing did not exist for the most part. Well, it might have existed, but it wasn't in common practice, and I'm not going to go down that rabbit hole. It's not my history to try and teach out. In digital mode, we have full operation, right? So that differs quite a different, words. It differs quite a bit from, let's say, AM or sideband operation. The closest to that would be, we'd be using this on FM. If that makes any sense. So, needless to say, what we've got to do is upgrade all wires. The plug, we want to try and keep the current and the voltage up as much as possible getting into the equipment, and we want to put more air through it. So we know what we're going to see on the inside of this. More poopy power wire. It's okay. We've got the cure for it hanging right above me here on the wire dispenser. I do need to call him back and find out if he wants to do the Anderson clip upgrade to it, or if he's comfortable staying with the Clinch Jones plug. We'll find that out. The Toshiba is becoming a more and more expensive upgrade. New ones are silly expensive, like silly. I think I've got enough used ones left around here that we can upgrade him with used and give him that price, but I cannot wait to see what we find inside. Usually on MFJ products, even though they're not in business, no offense y'all, MFJ's soldering is, well, deplorable, to put it mildly. Another thing I've had happen is here recently, I had this coax connector right here explode. I've repaired it. I put a new cap on it, a new adapter from the Bird 43, and a new PL259. You will see in upcoming videos here probably within the next week or so where this gets upgraded and all of this is going to get changed. We're going to go and we're going to upgrade to LC. We're going to go to 218 coax down to the dummy load. We're going to make it so this can't come apart again. The problem I've had, and it has shown up in multiple videos where I'm testing 3,000 amplifiers and bigger, where the loss of the amount of watts going through the 90-degree connector, the Bird 43 connector, the PL259, SO239, PL259, SO239, PL259, SO239, PL259, and SO239 is causing so much heating that we had some problems in the past where I had to literally cut the video off and let everything cool down. We're going to make it so that we can just slam whatever we want in here. You'll see, it's kind of cool. Everything that's PL259 or SO239 is going to get upgraded to LC connector. And then we're going to have coax bigger than our thumb. Well, bigger than what did Debbie in Dallas, you know, because she was a little run through and she came back from her trip from Dallas. You know, just saying. We're going to change all that. So we can look forward to that coming. I'll break that out in its own separate video, of course, because that's the way we do things. But back on topic on hand, let's get the lid popped off of this, because this would be a prime example of what the last version that come from MFJ before they went out of business, otherwise Ameritron. So let's take a look for typical. This I never understood why they went with the dual 5 amp relays. These aren't MFJ brand. These are SCH rack, SCH rack. You would think the cost of development of the board, the development of, I mean, there's a bunch of little pins and adapters and all kinds of crap here. Why didn't they just go with like a Japanese relay for like 10 bucks? I don't know. I don't know why MFJ did anything. I'm sure that their pencil pushers said that this was a better option. What it does have going for it is the anodized heatsink. It's the same board design that we've all seen a million times in here, right? This thing is in pristine shape. You can tell this guy doesn't smoke or anything like that. This has actually got 5 watts in it again. There for a while they were using 2 watt resistors in here, and I think it was probably because that's all they could find. I don't see anything obvious in here that screams at me and says I've broken. You know, usually this will yell at you and say, I'm broken, look here, like these will be burned up, that kind of thing. But I'm not seeing that today. We'll piggyback directly onto the fan leads so we can capitalize on the thermal cut on, cut off circuit in this thing. And, you know, I don't know how he's using this. I know he's using this as a base amplifier. We can utilize the fans turning off, and we'll just direct force air cool this corner of the board and it'll exhaust right out of here. So when this turns on, the fan on the lid that we're going to add will kick on at the same time. Well, I don't see anything in here that's screaming at me that says I have problem, but that doesn't mean nothing. I should probably go ahead and run this before I start pulling parts out of it. Yeah, man, there's all these adapter plugs on this relay, and so why wouldn't you just use like something like this? See, I buy these come out of Japan, right? And they're not expensive. Like this here. Perfectly good 10 amp relay. This will do the job. This will easily handle 500 watts. Just saying, you'd think the cost. I understand the open frame relay that they were using was a little bit more expensive. But to me, I look at this and I go, why? But who am I to question anything, and it doesn't really matter anymore. Upgrading the relay wouldn't do you any good. So before anybody has that conversation with themselves in their head, this is more than adequate. That is, well, adequate. Not woefully inadequate, it's adequate. So call that a win for them, I guess. Let's hook this up real quick. All right, are we booted yet? Kind of booted. Kind of booted. All right. It doesn't really matter. We're going to change all the transistors in here anyhow and upgrade everything, but I still wanted to test it. So we got it on like 14.3, so by the time we see in here, or 15.3, pardon me, by the time it gets down into here, it'll be around 15 volts. Let me reach down here and back this down a little bit. Okay. So 5 watt slug in reverse, 1000 watt in average, 1000 watt in peak. Let me show you radio drive. We're on 80 meters. Hello. Right at our 80 watts that everybody's known to come and love out of the ICOM 7300. Hello. Oh, it's sick. Hello. 1, 2. Yeah, I'm only able to get 300 watts out of this thing. So what's not happy in here? Well, all of it. Okay. Combiners are getting hot. Everything's getting hot. So let's see here. Hello, 1, 2, 1, 2. Hello, 1, 2. Yeah, this transistor's bad. This one right here. So there's an imbalance. These work in a push-pull. So one transistor rectifies the upper end of the sinusoidal wave, and the other one rectifies the negative side of the sinusoidal wave. So this section has a bad transistor in it, and that section is good. Now technically all we have to do to fix this is to replace this PP100, the RFT, by the way, which comes from RF parts. PP100. This is 23K 23X-Q. Hello, 1, 2, and yeah. She's sick. All right, well, it's now time for me to call the customer and see specifically what wire upgrades he wants to do. This power wire, I don't think it's ever been hooked up to nothing, to be honest with you. This stuff here. The ground lead, you see I got all this extra wire looped up here? The ground lead comes out, one lead comes out and it goes directly to this, like right to here. The other one goes all the way around this big loopy-doop and then comes back over here. Which is bad, because then most of the current's going to try and run up one wire. And as we know, there's no direct connection from the plug to the board. They use the case, which is a good design. I like to do the case and have a direct wire. That's just me. So let's see how far he wants to take this. Let me make some phone calls and we'll be right back. Okay. So we're about halfway. I got the HG RFT PP100 transistors out. This is our bad one, by the way. The other three had gains like 2 and 3. I'll hold on to them just in case somebody needs them as a replacement, because they're worthless now to this guy. I'm here to tell you what. Toshibas are in. All nice and pretty like. Right. This takes way longer than y'all think. For this to be done right, this is a 3-hour endeavor to change out these transistors. That's to fully pull all the solder off the board, reflux everything, put it all back together appropriately so it never comes apart again in the future. A lot longer process than you think. So these are our 2 remote leads. You got to have this one constantly hot, and this one is the auxiliary wire, this red wire. That's the one that attaches to this wire on the harness. Okay. I just take and we'll attach them over here. Then I got to disconnect this relay connection, and I usually move it over here. So we'll take and we're going to relocate that over here, and then we got to put a little ferrite bead on it, a little disc capacitor, and some other things, because we don't want RF from the outside universe coming to the inside universe of this piece of equipment. Now for our fan, we are going to take and put a fan in this general area of the cabinet. We're going to put the fan on a voltage regulator, so the fan can always turn at the same consistent rate. Probably take our voltage regulator, we're going to mount it over here someplace. We'll use this as our heat sink. We'll use the fan body, the stock fan body, as our strain relief for our fan disconnect. The CB amplifier, just take and run the goddamn wire and be like, whoop, whoop, done, right? No, it's not that. We've got to do this differently. So I got to modify this because he said he wanted to go with a 175 amp Anderson clip. So this is the panel mount adapter. It's our 175 amp brand new Anderson clip with all the appropriate mounting hardware, DEMS, and DAT. So I got to modify the bulkhead to clear. There's a capacitor that's in here. This capacitor here, we got to make sure to clear that. If we don't modify the bulkhead mount, it presses down on this board and it'll cause problems in the future. Then we got to modify the cabinet a little bit too. Take some nibblers to it. Nibbish. Make it so it's a little bit easier for us to get the job done here. Then we'll do a chassis ground on this lug. So now we'll bring the ground wire and we'll attach it here. So I'll have 3 pieces of wire coming out of the ground lug. 1 will go here, 2 will go over to the heatsink, shortest distance to transistors. It's just better that way. It's just better that way. So moving right along, we'll get this done here in the next probably 2 hours or so. Then we'll hook it up. We'll give it a run through. So I'm going to hook this up, relocate this, get this son of a bitch mounted up, put in here, slide it in the slot. Once again, just like how Debbie did on her trip in Dallas. And yeah, lots of clearance on this board. I did notice on these later model amplifiers, they wised up, they heard words. Maybe they heard them from me, they heard them from somebody else. They went to Teflon coax instead of using that shitty foam-based stuff. Listen, I have a thing about coax, and I'm getting ready to do a whole video on coax loss, connector loss, and I'm going to present it to you guys in a way that you don't think about it, on the norms, right? I have a problem with foam coax. I don't think we should have foam coax in our lexicon as radio operators, me personally. I think it either should be, and when I'm talking about foam is I'm talking about the center dielectric. I'm not going to get too far down on this tism, but we have there we go. We have our center conductor, which should be stranded on anything that we're going to put in a mobile, has to be stranded. Then we have our insulation dielectric, which is this here, which is Teflon. And then we have our shield, and then we have our outer jacket, right? Me personally, I think if it's got foam here, you should not use it. I've just had too many experiences in my life where the guy burned everything up in his station because the coax got a little warm, and the center conductor, that's this part that attaches to the coax connector, wanders through the foam because the foam gets soft, and then it makes contact or has a burn through, and it goes to the shield and everything blows up. Too many experiences with that. So me personally, I think we should use either the hard neoprene, or we should use Teflon based wire. And my rationale for that is, well, let's face it, you save a couple dollars on your coax per foot. Like, you know, hard neoprene coax is going to be about 35 to 65 cents more a foot. You spend a little bit more money on your coax, and it actually saves you money in the long haul. Because foam-based coax will always fail you, and when it does, it usually takes a lot of stuff with it. And by the time you get everything repaired, from you saving 30 or 50 cents a foot, you've lost money. It's just a me thing. Okay. Both fans are off. Turn this on. So we're at 14.4. 14.7 coming out of power supply. Okay, so radio 111111. Little ICOM action, right? Hello, 1 2 1 2 1 2. Hello, 1 2 1 2 1 2 1 2. Hello, 1 2. We have more than tripled the airflow coming out of this cabinet. We'll let everything cool off just for a second because we've got it right now. It's probably 65 degrees in here. I got to rechange the temperature, bring it up, because the guy's house is set at 73 degrees all year long, according to him. So I'll have to get the shop to about 73 degree air temperature, let everything come to the same temperature, and then reset the thermostat on the inside. But I'll show you what I did on the inside here in a second. It's kind of trick. I'll explain to everybody what I've done, because now everybody's going to want to have this done, right? Everybody's going to want to have the 120 millimeter fan that allows you to get 3 to 4 times the amount of air through the cabinet. See, nope. Everything's shut off. Okay. So there is a voltage regulator to a voltage regulator here. There we go. There, we're finally free. Okay, so over here, what I've done is I've got a relay that goes to a voltage regulator. Now the relay, the fan is switched on ground, so the 12 volt is always hot from the switch. The positive wire literally comes over and goes to the switch. So I piggybacked off the switch and made it so that the 12 volt circuit switches to the relay. Now that's not what drives the relay. What causes the relay to activate is on the ground side, there's a voltage regulator that drives that fan, but only lets the fan turn at like 7.5 volts. Well, we got to have a little bit more voltage than that to get this fan to turn, but I wanted it to be slow. I didn't want it to be loud. So this is a 9 volt voltage regulator that's over here on the case. Okay, so when this thing starts, it's got a soft start to it, real slow. So you can hear this relay chatter just for a little bit. I'll probably put a capacitor across the legs on the cap, on the relay. This little tiny micro relay that's right here, this little orange guy. It's right here. I'll probably put a cap across them legs. It'll smooth out when the relay shuts, so it's not a soft start. So I'm having to use a 12 volt relay that's triggered off a 7 volt circuit to fire another voltage regulator that's got an untapped 12 volt source that we're knocking down to 9 volts to keep this fan from going into crackhead land with a bunch of noise. This guy's gonna be sitting there working his digital mode. He just wants to work as digital, right? So 1 2 3 4, about 600 watts. Hello, 1 2 1 2. Hello, 1 2. Hello, 1 2 1 2 1 2 1 2. So once the fan's hooked up and running and the relay's shut, there's no more chatter. But like I said, we're just testing everything here. Hello, 1 2 1 2 1 2. And believe it or not, most of our noise is coming from the internal fan. So it's a compromise. So this one's getting 9 volts, that one's getting 7 volts, that one's making more noise. That thing's moving 2 or 3 times the amount of air that little fan is. So there's no back pressure flowing out of this fan, so it's all complementing itself. And the amount of air that's coming through this heatsink is just epic. I love it. I think this is I think I'm going to end up having to do this to a lot more ALS-500s, I hate to say. So it means I need to buy, I was lucky I was able to find this relay, by the way. I'm going to buy more of these relays and a whole bunch more voltage regulators because I'm going to start burning through them fast. It's a 2 amp voltage regulator, so there's more than plenty to run this 0.7 amp fan. Just saying, it all adds up. Now, when this thing cools back down, which is having to do off of ambient room air because there's no pressurization, the fan will shut off. So let me clean this up a little bit. I want to put a resistor. No, I don't want to do that. I want to put like a 104 and a 103 across the positive and negative poles on the relay, and then I want to put a, not a very big cap, maybe 200 or 300 UF at the most, across the positive and negative poles of the relay itself to help it latch shut with a lower voltage as the unit is ramping up and turning on. Hopefully that all makes sense. Give me a few minutes to get this buttoned up, then I got to build the power plug for him. This is my bench one. We got to build the actual one that's going to go with the unit, and we're done. Amp's working, obviously. I get 600 plus watts worth of power with 100 watts going in. So, I mean, he doesn't even drive it that hard. Puts like 35 watts in it or something. You got to look at the notes. So everything shuts off. And if we didn't have the voltage regulator in play and we didn't have the relay in play, because the way this fan is controlled, if I was just to piggyback it directly on the fan, when you flip the switch down, that fan will turn on. So, okay, yeah, let's get to it. So a little clip around RF choke on the fan and a little bit of capacitance in the right places, and our problem is solved. So it was making this weird when it would first latch up, and it was the orange relay that runs this fan going, it didn't know quite what to do. There wasn't enough voltage to really get the fan to latch. So I put an electrolytic across that, and then put a 104 across that, and a clip-on ferrite on the fan to make sure no RF got into the actual electronics for the fan. Hello, 1, 2. Audio, hello. Smooth. Smooth startup, smooth shutdown. It's more moving air, right? Like legit. There's about the only thing that would make this any better is if we went and we put phenolic here, blocking off this corner, and force more air to come through the heatsink. Well, that's not a good sign. Oh, that's not a good sign. All right, so let's test this another way. We'll go to AM, set our dead key to maximum, which is 19 watts. I think our little relay might be dying. I think the little relay, its contacts might be burning up. We'll see here in a second. If not, it's not a big deal. I just go up to like a 5 amp relay. Waiting, waiting, waiting. Come on. I might need to replace that little relay. So I got a couple extras. Typical. Works perfect off camera 100 times. Turn a camera on, fault shows up. It's okay, it's all part of it. Learned a long time ago, you can't get excited about such silly things. You just got to work your way through it. See what happens when it shuts down. Then we'll try this again in sideband. Guess it's working perfect now. Might have something to do with the SSB operation. Let's see if we can get it to do it again. Hello, 1, 2, audio, audio. No, couldn't just piggyback it off the fan. No. Gotta go the hard way, voltage regulator, relay, a bunch of switches. Isolation capacitors and freaking RF dampening friggin' resonant capacitors. Blah, 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 blah. Diodes, and partridge in a pear tree, Magandria. Oh, I'm going to bed. I'll dick with this in the morning. Good night, y'all. This is the coolest temperature it can see, which is 72 degrees. That's the ambient room temperature. This is the exhaust temperature of the amplifier, right here on the crosshairs. And this is the hottest temperature it sees in the overall field of view. So the guy has his house set, temperature set, at 73 degrees all year long, okay? So the idea is to have this thing kick on about 75, 78 degrees, somewhere in there, and kick out about the same temperature. Otherwise the fan will run all the time because of ambient air temperature, right? But because of the mode of operation he's using this thing in, we want to get the air on the amp as quick as we can and then have it come off when he's not talking on it. So let's just sit here for a minute and let's see where this ends kicking out. It ends up kicking out here at 75, 74, something like that. I'll call this a win, right? $75.7. Fans just kicked off. All right, so that is set. Now, for the customer, and for any of you that are watching, I want to show you this on the inside. So let's come forward a little bit. This blue potentiometer right here is what controls the fan kicking on and off. So if we take and we turn the fan potentiometer this way, that makes it kick in at a lower temperature, and then if we turn this way, so clockwise, makes it go up in temperature, counterclockwise like makes it go down in temperature. When the fan kicks in, when it kicks out. It's all controlled through this blue potentiometer, this one right here. We don't want to touch these other two, but if you do need to make adjustment, and I'm saying this to the customer, that's where you'd make it. It's on that blue potentiometer. Well, let's see, we're on 80 meters at the moment. We've got this thing floating at 14.9. We're going to put 100 watts in it as drive. 1, 1, 1, 1, 1, 1. Hello, 1, 2, 1, 2. About 600 watts on 80. Of course, the fans kick on. So now, let's change our point of view again. Let's see here. Go up in frequency. So this is 7.127 megahertz. Hello, 1, 2, 1, 2. We'll We'll go up again. And we'll say we're around 14 megs. Hello. Nope, we just overloaded it. Cycle it. No, that should work just fine right there. Let's see here. Yeah, 14 through 10. Hello, 1, 2, 1, 2. Yep. Change the band back. Hello. Just went into trip fault. It's perfect. Working just the way it should. So now we'll go on up to aux position. So we'll go to 10 meters, 28 megahertz. Hello. Directly into fault. Hello, 1, 2. Hello. Okay. So now we got to make a couple little more adjustments to it, but we're almost there. Hold on a second. I don't know why it was so sensitive there on 10 meters. It does work just fine, but I wanted to show you guys this. So now we're on, let's see, 60, 80, 40. We're on 20 meters. God. Believe it or not, it's nighttime again. It's a completely separate day. Now we're on 20 meters again on 14 megahertz. Hello, 1, 1, 1, 1, 1, 1. Hello, 1, 1. So we're putting about 100 watts in this thing. Watch this. Hello, 1, 2. Hello, 1, 2. It really puts out the shmoo. Now that's when it's on the 8 through 14.5 megahertz, right? So 8 megahertz through 14.5 megahertz. Hello, 1, 2, 1, 2. Hello, 1, 2, 1, 2, 1, 2. 700 plus watts peak with 100 watts drive going in on 20. So let me get the notes out, because the last thing I want to do before I let you guys go is I want to emulate what he's got going on. I use digital modes F8 and F4, usually drive 25 to 30 watts on sideband. 25 to 30 watts on digital, 65 watts on sideband. Okay. Let's go ahead, let's set this up. So go to peak. That's about 60 watts worth of drive. Haven't changed bands. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Hello, 1, 2, 1, 2, 1, 2. Yeah. Hello, 1, 2, 700 plus. Hello, 1, 2, 1, 2. Really? Hello. Okay. Hello. 675. So let's go ahead and let's run this down. Hello. About 30 watts of drive. Hello. 1, 2, 1, 2, 1, 2. Hey, you're going to see some dramatic increases in power output on your end, my friend. Well, Mr. Matt, you're done, my bud. It's a pleasure getting to hang out with you and talk with you on the phone this afternoon. Thank you for giving me all the answers and talking me through this. Thank you for letting me do your amp for you. And we're going to button this thing up. We're going to throw it in the box, and we're going to send it back to you tomorrow ASAP. Gentlemen, my name is BBI, and without a shadow of a doubt, I'm the biggest mud duck in Idaho, by far, bar none. Thanks to my Patreon supporters for making this entire YouTube ad-free, this video. Got a lot of fun stuff going on, getting ready to do another big, huge release from Penna. Looking forward to that coming up here in the next few weeks. All in all, this was fun. This was a neat little experiment. I'm liking how this is working. I don't know if I'm going to implement this on every single amplifier, because it does take a lot of time, but of course it'll take less time now that I've already done it once. Matt, don't hesitate to open this up and adjust the temperature potentiometer to you seeing fit. It's obviously working just the way it should. I didn't point out that I upgraded relays and changed a couple of things in here, and that's what made it more reliable enough to where I can let this go and feel comfortable with it. So, hello, 1 2 1 2 1 2. This is with 30 watts of drive. Hello, 1 2 1 2 1 2. All I got to do is put a sticker on the lid and my work here is done. Gentlemen, I say thank you. I mean this honestly. I get to say this from the bottom of my heart. I mean it truthfully. If there's anything I can ever do to help any of you guys out, any questions I can answer, anything, don't hesitate to call that phone number. I'm open 9 to 5, Monday through Friday, just like everybody else. On that note, gentlemen, I say thank you from the bottom of my heart for letting me be here and letting me work on all these cool projects for you guys. I'm off to the next one. RO number 53 is in the books and out the door. I'll see you guys. Click, click.